Okay, here we go. Module 36, energy, resources, and consumption, fuel types, and uses. So hopefully a lot of this is review. Some of it you will probably, maybe not know. Our learning goals today are identify whether the sun is the ultimate source of energy for many fuels. So does everything come from the sun? Pretty much. Okay, describe the major fuel types and how they're used. Identify other uses of fossil fuels and describe electricity generation and cogeneration. So this is kind of a bigger module, and I recommend giving it a read over in your textbook as well, just because it'd be possible to cover everything with this one. Okay? So, your first standard, identify whether the sun is the ultimate source of many fuels. The sun is the ultimate source of many energy sources on Earth, both renewable and non-renewable. Okay, biofuels are biomass that's processed and refined into liquid fuels like biodiesel and ethanol. Biodiesel and biomass make up 40% of renewable energy and 5% of energy consumed in the United States today. Okay, how are those things related? How is the sun related to biofuels? Take a guess.
Because plants use the sun to grow.
Yes, plants use the sun to grow, but how does that get into our energy resources?
Because it's like dead plants. It's also dead animals that eat the plants.
Yeah, good. So the sun, it grows the plants. Animals eat the plants. Plants and animals die. They decompose for millions of years, turning into fossil fuels, right? Okay. Another biofuel, okay, we could talk about is oils. So like vegetable oil. If you convert your car into a green car before electric cars were really a thing, you would take like the used grease and stuff like that from restaurants where they fry their French fries and that kind of stuff. That's animal oil, but you could also use plant oil like that you cook with to run these cars. And so if you burn biodiesel, it's got a little bit of that in it. It's kind of cheap. It smells like French fries running down the road. Okay, so the sun is the ultimate energy source. You guys probably know that, but just to reiterate, okay. This is one of your review questions. So, which one of these ultimately started, or which pair of these ultimately started with the sun? The answer is going to be your fossil fuels, and then your hydroelectric is the correct answer on that one. And the way that works is, again, we just talked about the sun grows the plants, right? Things eat the plants, and they decompose and turn into fossil fuels over millions of years. Okay. Then the sun goes into solar, obviously. Okay. We will use, or some places use manure, the methane that comes from manure to power their farms and things like that because it's a clean burning fuel and they're already naturally getting it. Okay, the one you might not think about is hydroelectric. You think, oh, that's water. But how do rivers keep flowing? We got to have some evaporation and bring it back to the top, right? Okay, so the water cycle, that's caused by the sun because if the earth was cold, there would be no evaporation, which means there would be no precipitation at the top to bring it back down. Does that make sense? Okay, so think about that. Good. Another one we don't really talk about a whole bunch is tidal energy. So when I was here all days, there was a big push to us to use energy from the ocean. And so essentially what's happening out there is like there's buoys that are absorbing the energy from the tide, pushing it in, and that's converting it into energy we can use for houses and things like that, which is pretty interesting. It's just not cheap enough to do it all the time yet. And that's controlled by the moon. So if you don't know, the moon and the sun control our tides, which is pretty interesting. Okay, so the sun is tied to like everything, which is kind of neat. Okay. So both fossil fuels and biomass raise atmospheric carbon concentrations. Carbon recently found in the atmosphere. Atmospheric biomass is called a modern carbon. Carbon that's contained in fossil fuel for millions of years as recently been released is called a fossil carbon. So modern carbons are examples of what, do we think? What would be an example of a modern carbon that you have seen probably in your lifetime? Okay, so carbon uses a fossil carbon, right, because it's using fossil fuels, but what's something that would use a modern carbon? Okay, so modern carbon is carbon that's recently found in the atmosphere. So you're a modern carbon. When you breathe out, that's modern carbon because you haven't been living that long. Another way would be like, so when you eat animals, right, or plants, that would be a modern carbon. trees are a modern carbon. Okay, when we use trees to fire up our boilers to run energy through a generator, okay, trees would be considered a modern carbon. Yes.
Some of them technically be considered fossil.
The trees. Depending on how old the tree is, I'm not sure where the cutoff is, but yeah, technically, if you have like a 1,000,000-year-old tree, I don't know. They found like the oldest tree not that long ago. I don't remember how old it was. Okay. So talk to the person next to you. Given that both fossil fuels or fossil carbons and biofuels both put CO2 in the air, is there one better than the other? Talk to the person next to you. Would you rather use a modern carbon or a fossil carbon? What do you think? Go. I'm going to count 30 seconds in my head.
Yeah, listen to it.
So which one do you think would be better? Or modern carbon or fossil carbon? What's your guess?
Yeah.
Like which one's better?
So you just like.
Okay, about 15 seconds left.
Like fossil fuels are battery miners, like fossil carbon. You should know what your discussion yesterday.
All right, and 3, 2, and 1. That front table to the right of me, do you guys have an opinion on fossil carbon versus modern carbon? Which one do you think is better for the environment to use? What? Why?
Because fossil fuels are like really bad for the environment.
Okay.
So like, you said modern carbon is like trees and just like breathing out.
Mm-hmm.
They're animals, so it seems like less, like not as bad.
Okay, yeah, cool. Anybody have a different opinion? Or one, maybe a different reason for choosing the same option? Janae?
For biofuel, it's less. It has less of an impact, I think, on the environment whenever you harvest it versus extracting fossil fuels, and then also biofuel, I think, because it's more expensive to harvest it, so it's used less than fossil fuels are.
Okay. Anybody else have anything? Okay. Okay, so we'll answer that in just a second. But here is, in your textbook, it says that people often confuse coal versus charcoal. So coal is on the left, okay? Charcoal is on the right. Charcoal is what you use in your barbecue grill. Coal is what they use in trains, okay? If you try to use coal on your barbecue grill, it probably wouldn't work very well. It takes a lot of heat to get that released, okay? Anybody know what charcoal is? Yes.
Isn't it like just really compacted wood?
Yeah, so most of the time it is wood that they've like pre-burned for you, and then they can pack it into those briquettes. If you've ever seen like a smoker, they usually will have like charcoal, like branches and stuff like that they'll use. Okay. So the question from earlier is: it better to use a modern carbon versus a fossil carbon? Okay, the general idea is that it's better to use a modern carbon because that has at some point taken CO2 out of the atmosphere within your lifetime, right? So dinosaurs and things like that have been in the ground for millions of years. We're taking the carbon that's in the ground from a long time ago and putting it back into the atmosphere. Whereas if you're taking down a tree, okay, that carbon has only been around since your lifetime, so you're just releasing carbon that was there not that long ago. Does that make sense? A little bit, maybe.
Yeah.
Yeah. Okay, so you're
Newer, less amount to put it out.
Yeah.
If it's older, it's gonna put a lot more.
right. So carbon neutral is what we're trying to get to. So we're trying to release the same amount of carbon that we are absorbing in, whereas fossil fuels, you're not going to do that because that's millions of years old. Does that make sense?
Yes.
Okay, so another example of that, like a modern carbon that they're making, is they're using like plankton in the sea, and they are turning it into biofuels. And plankton are really productive, and algae are really productive at taking carbon dioxide out of the atmosphere and doing photosynthesis. And they're really fast at repopulating, right? You guys saw how quickly we got algae in the fish tanks, right?
Right.
Yeah, same concept, right? And so we're taking carbon out, and if we can use it as fuel, it's really not adding any more carbon back to the environment. It's just using what was there like a week ago. Yeah, renewable carbon essentially. Okay, so common fuel types include wood, coal/peat, natural gas, crude oil, and tar sands.
What is
Wood.
peat?
What?
What is peat?
You're gonna find out. Yeah, it's pretty much like a prequel to coal. Yeah, so wood provides heating and cooking to 2 to 3 billion people in the world. Imagine if you had to use wood to heat your house, had to, not choose to, and to cook your food. It would take a lot longer, right? Yeah. 3 million homes in the United States still use wood as a primary heating fuel. That's not that many compared to how big the United States is, and it's usually in more rural areas. Okay, currently forests are being cut too fast to allow trees to maintain carbon neutrality. So if they were selectively cut, we probably would have more of a carbon neutral environment, but our population is growing, right? And especially in those developing countries where their population curve is still going up, it's not going down like ours is. You're going to have more need for more homes, which means you're going to need to fuel them and heat them and cook for them, right? Okay. So coal is a solid fuel that comes from the remains of trees, ferns, plant materials preserved 280 million to 360 million years ago. It's typically used for electricity generation in industrial processes that can be found in many forms. So there are different types of coal. We have peat, which is partially decomposed organic matter like mosses. Okay, we have lignite, which is soft sedimentary rock with traces of plant structures. So it's 67% carbon, also called brown coal. Bituminous coal, which is black or dark brown coal with bitumen in it, also known as asphalt. Okay, you guys see any asphalt around here? Most of your streets are asphalt. Okay, I don't think that's concrete, but okay. And then you have anthrite, which is hard coal, which generates 90% carbon. It's the highest energy per volume. Yesterday we talked about that's why we use gasoline in cars, right? Because it's the highest energy for the amount of space that it takes. It's actually really efficient. Okay, so I'm not going to go over this too in depth, but this is kind of where it gets from peat to the hard coal. So peat is about 50 meters thick. Okay, on the top level, so it's probably like your H or your F horizon of your soil. So it's going to be below that. Okay, your lignite gets even further from there, and it just with heat and pressure starts to combine, just like sedimentary rocks. Okay, but it's coal. Okay, next type of fuel is called natural gas. You're probably familiar with this. It's considered a cleaner source of combustion due to its smaller amount of particles, sulfur dioxide and carbon dioxide, compared to coal or oil. Most of this gas is methane, so CH4, and the remaining methane is propane and butane. It can be compressed and liquefied for transport. Natural gas comprises 24% of total energy consumption globally. So this is not the gas that you put in your car. This is the gas that you might have a big tank on the outside of your house where it gets stored. Or if you have a gas furnace or gas stove, it's usually powered by this type of gas. Okay, it's usually cleaner burning, which is good, so that way you don't get like a headache when you're cooking. You use it on like a propane grill. It's using natural gas. You can buy it at the store. If you ever go camping, you probably have a butane stove. Okay, and you can buy that at Academy Sports. So natural gas. If you've ever seen like, there's a TikTok going around where this couple is using like only sustainable materials and they're living off the grid, and they use a compost pile and they put like a big tarp over it and it catches the methane from the decomposition, and they use that methane, they funnel it to cook with. So pretty cool. But for free.
Well, there we go.
Okay.
I see it from right here.
Crude oil is a mixture of hydrocarbons such as oil, gasoline, kerosene, as well as water and sulfur that exists in a liquid state underground and when brought to the surface. Oils used in vehicles can be fried into a variety of compounds. So this process of boiling, you get a variety of compounds such as tar, asphalt, gasoline, diesel, kerosene. Okay, so when you hear about barrels of oil from other countries or crude oil, that's what you're putting in your cars. Okay, that's what they're making roads out of. That's what they're using to put the shingles on your house. All those things are oil, right? And so as 16, 17, 18-year-olds, you should all be pretty familiar with oil. It's what you use in your car to lubricate your engine. That way it doesn't seize. Or you should be doing that. Please get your oil changed. Questions so far? This is just this is an information dump. There's not a lot of practical thinking. Okay? This slide right here shows you the different boiling points of these types of fuels. And so what happens is they will take this crude oil barrel, they're going to heat it up, and the lighter stuff is going to have a lower boiling point, so it's going to go up a little bit further on their distiller. And so like your Bic lighters, your butane, your propane, all those things are going to go to the top of this colander, and they're going to capture it like that. Whereas your heavier things, your residual oil or your gas for your car, are going to be a little bit lower because they have a higher boiling point, so they're not going to float as high. Does that make sense? Yeah, so they're going to siphon it off at its different levels, which is kind of neat. Okay. A while back, you had an FRQ that asked about tar sands. We haven't really gone over it. I was pretty generous on that. But tar sands are slow-flowing, viscous deposits of bitumen and asphalt mixed with sand, water, and clay. Due to the oil near the surface, it no longer flows and it's mixed with sand and oil. If it's extracted, it can have a lot of negative environments or negative impact on the environment. So I don't really know why you would choose to use this, because it seems like it's a pain in the butt to separate out, clean it, refine it, and also you're doing damage to the environment because you still have to extract it a little bit, and then you're going to add a lot of CO2 to the environment, transporting it, refining it, etc., etc. So I don't really think it's worth the time. Yes, Janine.
Where would you find something like that?
Yeah, so Africa would have their deserts and that kind of stuff. Where you find that? I don't think you're gonna find that anywhere in the United States. Probably more Middle East. Probably not Africa. That's wrong. Middle East would have some of those things.
Is it just a really icky pond?
I guess, yeah. I was trying to find a good picture, and this is the best that I could get. I'd never heard of it before this class. I had to look it up. Okay. It's not one that we use probably a lot today. All right. So we're on our third standard, and that is identify other uses of fossil fuels. So fossil fuels highly specialized to be used in your motor vehicles and electricity. All conversions of energy lose efficiency, but there are methods to capture as much as possible. The modern design electric water heaters are 99% efficient. So when you're talking about energy, it's impossible to have 100%. Okay, you can't have 100% efficiency because as you convert energy from one thing to another, you lose it in the process of conversion. But water heaters electric water heaters are the closest you're going to get. And the reason is because your electricity will come into your electric heater supply. And instead of being lost to the environment, it is lost to the water that's in there. So the water absorbs the heat. So you're losing the least amount of energy possible in an electric water heater, which is kind of interesting. A gas water heater is only about 60% efficient. And so you can probably see why, because it's heating this up, but you're still losing energy out this way, whereas this is completely submerged in the water. Does that make sense? Yeah. So the electric is losing heat, but it's losing it to the water, and that's the whole goal of the water heater, right? The propane is losing heat, and so it's losing it some into the water, but some just into the environment. But where do you think the power for this comes from? For your electric water heater, is it really that efficient? Probably not, right? Because you have to have that energy from somewhere, and so living in the middle of Missouri, you likely have it from a fossil fuel power plant, right? Okay, so that might actually be less efficient overall than this one that's just natural gas going to your house, because you're going to lose energy as it comes to your house, right? Yeah. I don't know. That's a good question. I think some people prefer gas. That way, if the electricity goes out, they still got hot water. I've seen, like, I stayed at a place recently that had a new gas stove in it. So it's in, yeah. Okay. So 35% of energy use in the United States is used for transportation of people and goods. Public transportation is the most efficient model of transportation. Okay. Single driver cars and larger vehicles like SUVs and cars are the least efficient. Electric cars and plug-in hybrids make use of energy or electricity as an energy source. And then your book thinks that in the future, driverless cars can be programmed to take more efficient routes. Okay, so instead of waiting in traffic and burning that fuel from your engine, you take a little bit more efficient route and not be waiting as long and idling. How could this number be lower? So it says passenger car, gasoline, driver alone, no passengers, compared to Amtrak, electricity, or bus diesel. How could this number be lower? Carpool, right? So Miss Collins and I, we cut this number in half. Okay, because there's two of us in your car. The more people you have in your car, the lower that number gets.
Save the planet.
Yeah.
And gas money.
Yeah.
So as 15, 16, 17-year-old, 18-year-olds, what does a car represent to you?
Freedom.
Freedom, right? Okay, especially in this part of the United States, it's not like you live in a big city, you can catch a taxi or a public transportation very easy, right? Correct? Okay, so having a car is just the way of life that we have. So maybe do your part by carpooling and then pay the person a little bit of gas money.
What's that?
What?
So I don't have any of the corporate with everybody always has a different skin.
You couldn't pick somebody up in the morning on your way to school?
I could, but like,
Okay.
they don't have to go to
You
work.
could-
random people?
Well, no, but like, if you know somebody who has the same first hour as you,
Oh, so we can pick random people off.
I mean, you can figure it. You can do whatever you want.
I think you stand out and have to like a robust everything like that.
Okay. So moving on to that fourth standard, describe electricity generation and cogeneration. This is where it gets a little bit curious. If you haven't been paying attention, now it's time to lock in because you do have a question over this. Okay. So electricity is gathered via conversion from a fuel or a resource. So a lot of times it'll work a little bit like this. You'll have a fuel like gas, and it's heating up water, and that's water's going to turn to steam, and it's going to turn a turbine. Okay. So the turbine, what's happening is it's moving. As it's moving, it's turning this generator, and this generator is taking this steam heat, and it's converting it into electricity. Okay, so that's generation. It's making the energy. Okay?
It's a long process.
It is a long process. But then we have another thing called cogeneration, because when we turn the turbine, do you think that's 100% efficient? No, you lose a lot of energy doing that, right? Okay, and a lot of energy just goes around the turbine. What they're able to do now is they're going to take the steam from that, and they're going to put it through a transfer unit. They're going to turn that steam or hot water, and they're going to cool it back down. As they're cooling it back down, energy releases, right? Yeah, because we know that when you have a lot of energy as a substance, you turn into a gas. And whenever you turn back into a solid, you lose energy. Chemistry people, yes? Okay.
I was listening.
Yep, sure. Okay.
I was looking at you.
Okay, so an energy carrier, like a source of electricity, can move and deliver energy in a convenient, usable form for all users. Energy conversion right now is only about 36% efficient, and fossil fuels can release many pollutants in this process. Okay, so even though it's getting more efficient, we're still using fossil fuels, which is bad for our environment. We know about carbon and greenhouse gases and warming of the earth, right? Okay, all thermal power plants work on the same basic. They convert potential energy into electric energy. That's what we just looked at. Some natural gas-fired power plants use both steam turbine and a separate turbine powered by exhaust gas to generate more efficient electricity, a combined cycle. Okay, so this is the combined cycle right there. We'll go back to it in just a second. Okay, some good vocab words to know. The capacity of a power plant is the maximum electrical output it can handle. Okay, so how much electricity can it put out? The fraction of the time a plant operates in 1 year is known as capacity factor. Okay, that'll be a math term you might need, but not today. And one way to increase efficiency of fuel source is to practice cogeneration and combined heat and power, which uses electricity and heat to power a building or an industrial process. So that's what this is, right? So we have cogeneration, where we have generation where the turbine is turning the generator, which is turning it into electricity, and a cogenerator where it's catching some of the inefficient loss and it's creating more electricity. Okay. All right, so that is it